Hello there, and then welcome to a brand new lesson. This is How Beyond Numbers, where we learn maths the easy way. Now, in this lesson, we are looking at similar triangles. We will go through the proofs. First of all, going through the terminologies we need to know, and then afterwards, we can also solve some examples. So, without much ado, let's quickly look into it. So, first of all, what does it mean when we say two triangles or geometric figures are similar? When we say two triangles or generally two geometric figures are similar, we simply mean they have the same shape but different sizes or potentially different sizes. So if you look at these we have over here, this here can be said to be a scalene triangle because all the sides are different, you see. And this also is a scalene triangle, but then this is bigger than this. But then they all are scalene. You see, they are all scalene triangles. On the other hand, what we have here is a right angle triangle, and this is also a right angle triangle. So they are having the same shape, but then it's just that their sizes are different. You can't say a right angle triangle is similar to a scalene. They are, even though they are all triangles, but they are of different what shapes. You see, they are different types of triangle. So simply put, two geometric figures are similar if they have the same shape, but potentially different sizes. Now, the symbol for similarity is what you see over here. So it's just something like this, as you can see. So something like this. Okay. So with that said, the next thing we need to understand before we can get to this whole concept is corresponding angles. Corresponding angles. So talking of corresponding angles, angles that are in the same relative position in two triangles, they are what we call corresponding angles. Now, if we look at these two triangles I've drawn over here, if we want to look for the corresponding angles, you would first of all have to align the triangles such that they look the same. What do I mean by they look the same? So look at how this has been aligned. I'm going to reposition it this way so that it looks something like what we have up here. You see, this is a better presentation than it being like this. Okay, so you arrange it well. Now, if you are able to arrange it well, you can now look at their relative positions. What do I mean by their relative positions? So for the one beneath, if I take this angle over here, you can clearly see that it looks like this angle over here. And we call them corresponding angles. You see, they correspond to each other. This angle here, on the other hand, can also be said to correspond to this because we have been able to position the shape in a way that we can easily tell which one comes from which. You see, then we can also say that this angle over here also corresponds to this. Now, take note, to confirm that the angles in question are similar, their corresponding angles need to be equal. They must be equal. It is something very important. So if you're able to position your triangles just as I have, and the corresponding angles are not equal, then you can simply say the triangles are not similar at all. You see, this is the next term you need to know. Now, we are gathering all this term before we go to the postulates so that we get to understand what each postulate says. Now, the last term we need to look at is the corresponding sides. Corresponding sides. So what do we mean by corresponding side? Earlier on, I illustrated or I demonstrated to you that this angle here is corresponding to this one. Now, if you look at the side that is facing our angles in question, this side and this side, we can call them corresponding sides as well. Why? Because you see the angles over here, they are corresponding and they are facing this side. Hence, this side here corresponds to this one. Simply put, provided you have been able to position your shapes well, if you fit them into each other with the corresponding angles, the sides that represent each of the angles is what we call the corresponding side. Okay, so with this we have over here, I can say that this side here corresponds to this, you see, and also this side over here correspond to this side, and finally this one here would then correspond to this. Now, what condition must be met so that we can say that corresponding side contributes to the similarity of the triangle? The condition is that they must be proportional. What do we mean by they must be proportional? Let's let the measure of this side here be an A. The measure of this side here be a B. The measure of this side be a C. In the same way, let's let this be a, let me say D. Then we have E, and then F. What do we mean by they must be proportional? So if I take this side and I'm saying it is corresponding to this side, then A over D, this is the D, A over D should be equal to, if I take the other corresponding side, so B over its corresponding side is E, and it also should be equal to C over, what do we have here, F. If this condition is met, then the two triangles are what? Similar. I took the big ones over the small one. You can also choose to take the small one over the big one, so that it becomes D over A being equal to E over B being equal to your F over C. The most important thing is, if you are using the small over the big, do that throughout. If you are using the big over the small, it should be the same throughout. Okay. Now, this gives you a ratio we can call K, or the scale factor. That is the scale factor. It shows how much, if you are talking of this, then it shows how much this triangle has been enlarged to give you this triangle. Or if you are talking of this with respect to this small triangle, then it shows how much this bigger triangle has been what? Made small, so that it becomes what? This one over here. So with all these established, let's now look at the postulates, the similarity postulates. So talking of the similarity postulates, there are three we'll be looking at. The postulates are just the minimum conditions required to prove that two triangles are similar without necessarily having to solve anything or checking all the six parts. The six parts here, I mean checking all the three angles and then all the three sides. You see, if you know these postulates, there's no need having to check all. The first one is the angle-angle similarity postulate. The second one is the side-side similarity postulate. And then the third one is the side-angle-side similarity postulate. So let's look at the first one, which is the angle-angle similarity postulate. It says that if two angles of one triangle are equal to two angles of another triangle, then the triangles are similar. So as you can see, I have this triangle here and I have this other triangle over here. If it is labeled and you are told that, okay, this angle here is the same as this angle here, and then this other angle over here is also the same as this angle here, then there's no need measuring anything, because you have been told that at least two of the angles are equal. You see, so you can quickly say that using the angle-angle similarity postulate, these two triangles are similar. Why? Because we have found out that at least two of the angles are equal. You see how very simple it is. Understand what the postulate says. Look at the triangles you have. If it satisfies that postulate, you make your conclusion. Angle-angle similarity postulate is saying that check the two triangles. If they have two angles equal, then if at least two angles are equal, then it simply means the triangles are similar. And that's the easiest of the postulates. Actually, they are all easy though. So let's look at the next postulate. Now, the side similarity postulate is saying that if the ratio of the length of the three pairs of corresponding sides are equal, then the triangles are similar. What does it mean? So let's take these two triangles we have over here. The angles have not been labeled, but then we have the sides being labeled. The side-side similarity postulate is saying that if I take the length of AB, if I take the length of AB, then I find its ratio with respect to what? The length of DE. I'm taking DE because they are corresponding sides, which we have looked at what it means. So if it is equal to, I take BC. So BC over the corresponding side is what? EF. And I'm also going to take what? AC. So AC all over DF. If all of this is worked out and we are getting a common answer, which we call the scale factor, then it simply means the triangles are what? Similar. That is all this postulate is saying. That is just all it is saying. So what you want to do is, you do not necessarily always want to use the bigger one over the smaller one. You can also use the smaller one over the big one. As I said in the previous one, just be what? Consistent. If you are using the small over the big, it should be the same throughout. So if you do that and you are getting the same answer, as you evaluated this, you are getting a K. You are getting a constant value, which is the same as what you get here, which is the same as what you've gotten here. You are actually using the side similarity postulate to prove that the triangles are what? Similar. This postulate actually comes with so many questions that helps us to solve for variables on what? For the sides whose values are not known. In our subsequent videos, we'll look at such examples. Let's look at the third postulate. Now, the last postulate we are looking at is the side angle side similarity postulate. And it says if two sides of one triangle are proportional to the corresponding side of the other, this time around we are limiting ourselves to 2, and the included angle between these two sides are equal or congruent, the triangles are similar. Since we'll be talking about congruence in our subsequent ones, let me just take this off from here. Now, what does this postulate actually mean? All it is saying is we want to check if the two sides are in proportion. So let's take AB over DE. If it is the same, if the ratio we get is the same as AC over DF. So provided we're given only two sides, right? Two on this triangle, two on this triangle. And then we are able to find their ratio, and we get the scale factor to be the same. And then we are not given the third side, but then we are given the angle between the two sides we picked. And the angles are the same. You see, that is what we call the included angle. So if the included angle are equal, then the triangles are similar. You see, then the triangles are similar. So all it is saying is you are being given two sides. Okay. Now, if you're able to find the two sides ratio and you get a scale factor, and in addition to that, you don't even have the third one. You remember, if we were to use the side similarity postulate, you have the third side. But for the side angle side, you have only two sides, you see, and then an angle. So if you find the ratio of the two sides and then they are the same and the angle between them are also the same, then we can say by the SAS similarity postulate, the two triangles are similar. This has been a very long one, and I know it's a lot to take in. Hence, I wouldn't be solving any examples in this particular lesson. We'll solve more examples in our subsequent lessons. If there's anything bothering your mind, you can always let me know in the comment section. And if this is your first time visiting this channel, let's have Beyond Numbers, where we learn maths the easy way. You can choose to subscribe if you so do wish, so that anytime I release a video, you'll be notified as well. See you in our next lesson, where we would solve more examples to explore these postulates. Bye for now.